This is the screencast for section 8.2, L'Hopital's rule. So L'Hopital's rule has two forms, the first form and then the stronger form. See that little brain? Yeah, it's cute. Alright, so the L'Hopital's rule, the first form, basically says that if you're trying to find the limit as x approaches a constant, of one function divided by another function, and the derivative of both those functions exist, you can just take the derivative, plug in a of both the numerator and denominator separately. Now remember, you cannot do that with taking the derivative of a quotient. We have the quotient rule for that. But in this case, if you're just finding the limit of those two functions, now you can take the derivative of the numerator and denominator separately. Now, the stronger form is used, and we'll use this actually all the time, but the stronger form is used if you have to take the derivative more than once. You're not plugging in a right away. Kind of like back when we did the original definition of a derivative, sometimes you could plug in the constant right away of f of a plus h minus f of a all over, x minus h. But then you could also just use x in it the whole time through and get a formula at the end. So we like the stronger form better. Now, why does this work? Why can you just do this? Well, here's the explanation. Well, if we start out by just trying to find the limit as x approaches a of f of x over g of x, we can rewrite that as f of x over x minus a over g of x over x minus a. So all we did was divide the numerator and denominator by x minus a, which means nothing. It didn't change anything. You're kind of multiplying by 1 over x minus a in both the numerator and denominator. It doesn't change the value. Well, if we want to rewrite that a little bit, let's throw a minus 0 on the top of each rational expression here. That doesn't change the value either, but now it looks like you're finding the slope between a comma 0 and x comma f of x in the numerator, and then a comma 0 and x comma g of x in the denominator. Well, as we all know, slopes are derivatives. So if we find that value at a, which we said the y value for 0 is f of a, and the y value for 0 is g of a, well then that is the derivative over the derivative. So you're taking the same exact original expression and just rewriting it, changing it algebraically, not numerically, just algebraically, to express it as a slope divided by a slope instead. So L'Hopital's rule does hold. So how can we use that? Well, L'Hopital's rule is great for indeterminate forms. Indeterminate forms, there are several of them that we will discuss in this section. The first one we'll look at is 0 over 0. Now, way back in chapter 2, you were already finding the limit of the 0 over 0 form, but your main ways of doing that were some sort of algebraic cancellation, and then you could finally plug in the number. Well, we can't do algebraic cancellations in this type of situation. So here's where we get to use L'Hopital's rule. So first, I'm going to graphically look and see what the limit is. Looks to be about 1/2 to me. So it looks like the limit of our function, square root of 1 plus x minus 1 over x, as x approaches 0, is about 1/2. So I know what I'm supposed to get when I do L'Hopital's rule. So L'Hopital's rule gives us a 0 over 0 indeterminate form. So that gives me a clue that I should be using L'Hopital's rule. So now I'm going to take the limit as x approaches 0 of our function, and I'm going to take the derivative of the numerator and then the derivative of the denominator. By L'Hopital's rule, those are equivalent. Well, the derivative of the numerator is 1/2 times 1 plus x to the negative 1/2, and then technically times 1, but that doesn't change anything. And the derivative of x is just 1. So now I have a situation where I can just plug in 0, and I don't get 0 over 0 anymore. As a matter of fact, I get 1/2, the limit as x approaches 0 of our function. Then now try problem number 3. It says estimate the limit graphically, and then use L'Hopital's rule to find the limit. Well, graphically, it looks like my limit, I put it x as 2.1, looks like my limit is going to be, as x approaches 2, 0.25, so a quarter. All right, so let's see then, using L'Hopital's rule, what that limit actually is. So I'm going to take the 2 and plug it in, and I do get 0 over 0, so I'm going to use L'Hopital's rule. I'm going to say the limit as x approaches 0 of, now the derivative of the numerator is 1/2 2 plus x to the now negative 1/2 over the derivative of the denominator, which is 1. Now I could just plug in 2 there, but algebraically that throws the binomial here in the denominator, and then the 2 goes down to the denominator as well. Now if I plug in 2, I do get 1/4. 2 plus 2 is 4. Square root of 4 is 2. I get 1/4.